problem, I have to graph an inequality. Well, just like when I'm making a linear inequality, I need to find the boundary lines for my inequality, decide whether they're dashed or solid, and then I need to pick a point and shade it to decide what side of the inequality, what side of the boundary line I need is going to be a solution to the problem. So in order to graph this, I'm going to start with my parent function, which is the absolute value of x. If you remember, we have a times absolute value of x minus h plus k, and whenever we want to find the parent function, we just get rid of the a's, the h's, and the k's, and we find that our parent function is the absolute value of x. So I'm going to start by graphing that. And I know from my library of functions, that's 0, 0, 1, 1, 2, 2, and that's going to be a line looking like that. And it's going to be a line looking like, oh, this is a very ugly line, like that. My next step is to transform this into, and I'm going from left to right, 1/2 absolute value of x, which means all of my y values need to be cut in half. So 0, 0 cut in half is still 0, 0. 1, 1 cut in half is 1, 1/2. 2, 2 cut in half is 2, 1. 4, 4 cut in half would be 4, 2. I can do the same thing on the other side, just cutting all my values in half. And I can see that my second transformation looks like this. Close enough. My a here is less than 1, greater than 0, which means it's a fraction, which means it is going to compress my parent function. My next part of the transformation is to do my h and k. Well, my h is -3, and my k is -1. So every point I'm going to move to the left 3 and down 1. So I'll start with my vertex, 1, 2, 3, down 1. There's my vertex, my new vertex. I'll do the point -2, 1. I'll go 1, 2, 3, down 1. It comes out to be right there. I'll do the point 2, 1. I'll go 1, 2, 3, and it comes out to be right there. And so my transformed graph looks like that. However, this is an inequality. So my boundary line is not going to be part of the solution. So that really should be a dashed line. Since I don't have an eraser and I don't want to do it properly, I'm going to go like this. Dashed. And I'm going to point to it. So now I've said that it's a dashed line, but now I have to find out, well, which side of this actually contains the values that work. So I can see that my line does not go through 0, 0. My boundary does not go through 0, 0, so I'm going to try that as my point. So I'm going to say, is 0 less than 1/2 the absolute value of 0 plus 3 minus 1? Well, is 0 less than, well, that would be 1.5 minus 1. Is 0 less than 0.5? Yes, 0 is less than 0.5. So the 0, 0 point, my y and my x there, that is part of the solution. So I know that I need to shade everything below my absolute value boundary there. Everything that is below my absolute boundary will be a solution to this inequality.